But what if I told you that the most rigorous theoretical physicists and ancient mystics separated by millennia are actually speaking the exact same language? Does that sound completely insane? Perhaps, but today we're embarking on the most exhilarating journey imaginable, travelling to the edge where quantum physics collides with mysticism and where science just might be extending a hand to God. Get ready, because what you're about to learn could permanently change your view of reality, consciousness, and your place in the universe. Science and faith. Are they irreconcilable enemies, or two sides of the same coin? Drop your thoughts in the comments right now, and we'll definitely circle back to them at the end of the video. Let's go! For centuries, the world felt simple, measurable, and easily understood. On one side, we had science, a realm of objective laws, hard facts, and tangible objects. Apples fall down, planets follow predictable orbits. Everything was measurable, quantifiable, and countable. On the other, there was the world of mysticism and religion, a domain driven by faith, intuition, subjective experience, and non-material entities. These two worlds rarely, if ever, intersected. Scientists often scoffed at the fables of the mystics, while the mystics dismissed scientists as blind individuals who failed to see the true nature of reality. But in the early 20th century, that all changed. A group of brilliant minds, Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg, looked deep inside the atom, and what they discovered there shattered the conventional view of the world entirely. Classical physics crumbled to dust, yielding to a strange, paradoxical new discipline, quantum mechanics. And it is this very science that constructed an unexpected bridge between these two seemingly incompatible worlds. So let's begin with the most fundamental shock of the quantum world. Imagine an elementary particle, an electron, for example. In our ordinary, everyday world, an object is just an object. A ball is a ball. It has a clear shape, and it occupies a single, definite location. But in the quantum realm, things are radically different. The electron, it turns out, can behave simultaneously as a tiny, localized sphere, a particle, and as a wave of probability spread out across space. This phenomenon is known as wave-particle duality. In essence, the fundamental building block of our universe can't make up its mind what it is. It exists in two states at once. To visualize this, imagine you are both a person sitting on a chair and the diffused possibility of your existence spread out across the entire room. It sounds utterly insane, but this is the foundation of the reality that makes up everything around us, including you and me. This was the first major clue that hinted to scientists that reality, at its most basic level, is far more fluid and undefined than we ever imagined. Interestingly, mystics have been saying for thousands of years that the visible world is merely an illusion, Maya, and that true reality is constantly flowing and multifaceted. But wait, it gets even weirder. Scientists then decided to test exactly how an electron decides whether to act as a particle or a wave. They set up the famous double-slit experiment. Here's the short version. When the electrons weren't being spied on, they behaved like waves, passing through both slits simultaneously and creating a predictable interference pattern on the detector screen. But the moment they introduced a detector to observe which slit an electron went through, it immediately collapsed, snapped back into behaving like a proper particle, and passed strictly through only one opening. This phenomenon was named the observer effect. The simple act of observation fundamentally changed the result. Do you realize the implications of this? Quantum reality literally responds to whether we are paying attention or not. While we aren't looking, it exists only in a fog of probabilities, what scientists call a superposition. But the act of observation forces the universe to make a choice and assume a concrete form. This was a massive blow to classical science, which had long maintained that objective reality exists independently of the observer. It turns out we are not just passive spectators in the theatre of the universe. We are direct participants, influencing the scene merely by paying attention. And this is where we encounter the first point of convergence with mysticism. What is the central doctrine shared by countless spiritual traditions, from the ancient Upanishads to modern New Age movements? It is the belief that consciousness shapes reality. We know the maxims: what you focus on grows. Thoughts are material. The world is a reflection of your inner state. For thousands of years, these were largely dismissed as beautiful metaphors or mere psychological coping mechanisms. But then, the observer effect in quantum physics suddenly injected this ancient idea with an almost literal meaning. Of course, most physicists are quick to point out that the observer is simply any measuring device, not necessarily human consciousness. Nevertheless, the core principle remains stunning. The very act of measurement, the act of acquiring information, fundamentally alters the physical reality being observed. Some bold thinkers, like physicist John von Neumann and Nobel laureate Eugene Wigner, took this concept further, suggesting that consciousness itself is the ultimate measurer responsible for collapsing the wave function. Perhaps the ancient sages, by delving deep into the process of meditation, intuitively grasped this fundamental law of the universe, a law that science would only be able to confirm millennia later using incredibly sophisticated instruments. Let's take a deep dive into an even weirder aspect of the quantum world: superposition. Until we measure a particle state, it exists in every single possible state simultaneously. This isn't just about observer ignorance, where we simply don't know its location. It means the particle is literally everywhere at once. The classic example is the thought experiment involving Schrödinger's cat. Imagine a cat inside a box where its life hangs on the decay of a single radioactive atom. According to quantum mechanics, until that box is opened, the atom has both decayed and not decayed simultaneously. This means the cat is also simultaneously both alive and dead. The cat is in a true superposition of two states. It is only the act of opening the box and observing the system that forces reality to make a choice, collapsing the possibilities and making the cat definitively either alive or dead. This concept is so counterintuitive, it's truly mind-bending. It suggests that before that final choice is made, reality is a pure field of boundless possibilities. All potential outcomes exist parallelly in the form of probability waves. This isn't merely a philosophical concept, it is a mathematically proven physical fact, forming the very basis for technologies like quantum computers. Now let's go back and put on our mystical lens for a moment. How does the concept of superposition translate into the world of spiritual practice? It introduces the idea that in every single moment, an infinite array of paths and future options are open to us. Until a definitive choice is made, all these potential outcomes are equally real. Esoteric teachings emphasize the power of intention, which, much like the act of observation in physics, collapses this field of possibilities, thereby materializing one specific version of reality. Many meditative disciplines are specifically aimed at achieving a state of pure potential, that crucial 0 point from which we can create any desired reality. Doesn't that bear a striking resemblance to a quantum system that remains in superposition until the observer intervenes? This suggests that our universe is fundamentally structured as a system of infinite potential, and our consciousness, our choices, and our attention serve as the key factors that transform mere possibility into actuality. Once again, ancient wisdom and cutting-edge science are describing the exact same underlying mechanism, simply using different languages. If you thought things couldn't get any stranger, then prepare yourself. We are approaching a phenomenon that Albert Einstein himself famously dubbed spooky action at a distance. We are, of course, talking about quantum entanglement. Picture this: you have two particles that were born together and are intimately linked. For example, let's say they have opposite spins. Now separate these particles by any distance, whether it's across the room or across the entire galaxy. The most astonishing part is this: the moment you measure the spin of one particle, you instantly know the spin of the other. It immediately assumes the opposite value. Instantly! This connection happens faster than the speed of light. It's like having two connected coins. If one lands on heads, the other, no matter where it is in the universe, simultaneously flips to tails. Information is transferred between them in some incomprehensible, non-local way. This fundamentally challenges everything we understand about space and time. Einstein hated this idea so much that he spent the rest of his life arguing that quantum mechanics was an incomplete theory. But countless experiments have since confirmed it. Spooky action at a distance is absolutely real. Once again, we see a striking parallel with mystical teachings. What is the central idea shared by most spiritual traditions, from Buddhism to Sufism? We are all one. Everything is interconnected. Separation is an illusion. Mystics assert that at the deepest level of existence, no boundaries separate me and you, a human and a tree, or even the earth and a distant star. We are all parts of a single whole, invisibly threaded together. Quantum entanglement, in essence, is the first hard scientific evidence supporting this idea. It demonstrates that at a fundamental level, a connection truly exists that defies the constraints of space. Two entangled particles behave not as two separate objects, but as a single unified system, even when separated by billions of light years. Perhaps the intuitive certainty mystics have about the unity of everything is not just a beautiful poetic metaphor, but a profound insight into the real architecture of our universe, one now confirmed by the most precise scientific experiments. We truly are all entangled. The phenomenon of entanglement introduces us to an even more profound concept, non-locality. In our familiar, local world, influencing an object requires physical contact or sending a signal that travels no faster than the speed of light. You can't simply move a rock on Mars just by wishing it from Earth. But the quantum world, as we have established, is non-local. In this realm, connections exist that act instantaneously, regardless of the distance separating them. This implies that, at the deepest level, the entire universe might actually be a single, indivisible whole. The physicist David Bohm expanded on this idea, suggesting that our visible, seemingly separate world is merely the explicate order, a kind of hologram. Hidden behind it is the implicate order, where everything is merged and unified. In this deeper order, any single point in space holds information about the entire cosmos. This concept strikingly resembles the Hindu idea of Indra's net, an infinite cosmic web where a jewel is placed at every intersection, and each jewel perfectly reflects all the others. Mystical traditions are packed with concepts that directly parallel non-locality. Consider, for instance, the idea of the collective unconscious, famously proposed by psychologist Carl Jung. He theorized that beyond our personal unconscious, we each have access to a shared informational field common to all humanity, a field containing archetypes and shared memories. How do we explain synchronicities, those meaningful coincidences that simply defy explanation by mere chance, or phenomena like telepathy, clairvoyance, and even prayer, described across all cultures as the mind's ability to influence events remotely? From the standpoint of classical physics, these things are simply impossible. But within a non-local quantum universe, these concepts no longer seem like total science fiction. If, at the deepest level, we are all part of a single, unified informational network, then the instantaneous transfer of thoughts or feelings across distance ceases to look like a miracle. Instead, it appears to be a natural property of the very reality we inhabit. Now let's turn our attention to what we generally consider nothing, the vacuum. According to classical physics, the vacuum is defined as absolute, pure emptiness, zero presence. But quantum physics threw us a curveball here. It turns out the quantum vacuum is far from empty. In fact, it's teeming with energy. Constantly, out of nowhere, pairs of virtual particles and antiparticles are popping into existence, only to immediately annihilate and vanish. This rapid process is known as quantum fluctuations. The vacuum is less a void and more a churning cauldron, a supercharged reservoir of hidden energy and potential. By some mind-boggling estimates, The energy contained within just 1 cubic centimetre of this vacuum exceeds the energy of all matter in the known universe. This means everything we see, the stars, the galaxies, even ourselves, is merely a tiny ripple on the surface of this boundless ocean of energy. Our entire material universe may have been born from a single, giant fluctuation within this very vacuum. It turns out that nothing is actually the source of everything. Once again, this scientific understanding strikingly echoes cosmological myths and mystical concepts found across the globe. In many ancient traditions, the universe is born from primordial chaos, from a bottomless void, or from a primary, undifferentiated ocean. In Hinduism, we find the concept of akasha, the quintessential first element, a subtle, supersensory substance that permeates everything and acts as the source of all forms. Similarly, Taoism speaks of the Tao, the inexpressible, invisible origin from which the 10,000 things are born. All these concepts describe a field of pure potential that precedes the material universe. Quantum vacuum theory, essentially, gives these ancient intuitions a modern scientific name. What mystics refer to as God, the Absolute, the Tao, or Akasha, physicists today call the quantum vacuum or the zero-point field. It is the same underlying idea, that the foundation of our ordered world rests upon an invisible, yet infinitely powerful source of all existence. What's fascinating is that the founding fathers of quantum mechanics were acutely aware of the philosophical depth inherent in their discoveries. They weren't mere technicians just cranking out equations. Instead, they were profound thinkers, wrestling with what these discoveries implied about the very nature of reality. Consider Niels Bohr, for instance, who was so taken by the concept of duality that he incorporated the yin-yang symbol into his coat of arms. Beneath it, the motto read, "Opposites do not contradict, but complement each other." Werner Heisenberg, the originator of the uncertainty principle, famously wrote, "The first gulp from the glass of natural sciences will turn you into an atheist, but at the bottom of the glass, God is waiting." He personally viewed quantum mechanics as a profound return to the ideas of the ancient Greek philosophers. Erwin Schrödinger, the mind behind the famous cat thought experiment, was deeply absorbed in Hindu philosophy, particularly Vedanta. These scientific geniuses understood that they had touched upon something that extended far beyond the mere description of the material world. They recognized that a new physics demanded an accompanying new metaphysics. Let's turn our attention now to Erwin Schrödinger, whose fascination with Eastern philosophy ran particularly deep. He studied the Upanishads, the ancient Indian texts that form the foundation of Vedanta. The central tenet of Vedanta is the identity between individual consciousness, the Atman, and universal consciousness, the Brahman. That is to say, at the deepest level, consciousness is one and the same in all living beings. There is no multitude of separate selves. There is only a single, unified consciousness experiencing itself through a myriad of forms. And here is what the Nobel laureate in physics, Schrödinger, wrote about this, quote, "The plurality that we observe is merely an illusion. In reality, consciousness is always one and singular." He believed that the advent of quantum mechanics, with its principles of unity and interconnectedness, provided scientific confirmation of this ancient wisdom. Just imagine this, one of the greatest physicists of the 20th century, who laid the foundations for our modern understanding of matter, openly declaring that we are all aspects of a single, divine consciousness. These are not the words of a guru or a preacher. They are the words of a scientist who peered into the very essence of reality. Now, to keep this journey fair, we need to pause and talk about the criticism. It's important to understand that the mystical interpretations of quantum mechanics we are discussing are definitely not considered mainstream in the scientific community. The vast majority of physicists subscribe to the so-called Copenhagen interpretation, which famously states, "Shut up and calculate." They argue that yes, the quantum world is weird, but our equations describe it perfectly, allowing us to build lasers, computers, and atomic bombs. All this talk about consciousness, God, And unity? That's just unnecessary philosophy that only muddies the waters. Moreover, there's an entire phenomenon known as quantum mysticism, or more harshly, quantum quackery. This is when self-help gurus, coaches, and esoteric practitioners hijack scientific terms like quantum leap or vibrations to sell their training and give their ideas a pseudoscientific veneer. They pull complex concepts completely out of context and manipulate them to fit their narrative, which understandably infuriates legitimate scientists. Therefore, it is crucial that we separate the wheat from the chaff. The core issue skeptics raise is the problem of scale. Sure, at the subatomic level, the universe behaves bizarrely. However, these quantum effects almost entirely vanish when we transition to macro objects: dust particles, apples, cats, and humans. This process is called quantum decoherence. When a system interacts with its surrounding environment, it rapidly loses its quantum properties and begins to obey the familiar rules of classical physics. This is why, critics argue, we cannot simply take the laws of the microworld and apply them directly to our daily lives. Just because an electron can be in two places at once doesn't mean you can simultaneously be sitting at home and punching in at the office. The fact that observation affects a particle doesn't mean you can bend a spoon or cure a disease purely through willpower. This kind of direct application is a crude and inaccurate oversimplification, and on this point, the critics are undeniably right. The macroscopic world operates under its own, far more predictable laws. But the crucial question remains, where exactly does the boundary between these two realms lie? This is where some incredibly bold, albeit controversial, theories step onto the stage. These theories attempt to bridge the gap between the quantum world and the ultimate realm of human consciousness. The most famous of these is the theory put forward by Roger Penrose, a distinguished physicist and mathematician, and Stuart Hameroff, an anesthesiologist. They hypothesized that consciousness itself is fundamentally a quantum process. According to their model, this process occurs within microtubules, tiny protein structures found inside the neurons of our brain. It is in these microscopic structures, they argue, that quantum coherence can be sustained. This means the system maintains its delicate quantum properties, avoiding the phenomenon of decoherence, and this is also where the objective reduction of the wave function takes place, an event we perceive as an act of awareness or free will. This theory is highly contentious and has drawn significant opposition, but regardless of its validity, it demonstrates that serious scientists are actively searching for that crucial link between quantum physics and the most mysterious phenomenon in our universe, human consciousness. Perhaps our brain truly is the ultimate quantum computer, constantly collapsing the wave function of reality itself. Perhaps the correct perspective lies somewhere in the middle. Maybe quantum physics doesn't prove mysticism in the literal sense, but it provides us with a new, incredibly powerful metaphorical language to articulate the intuitive insights grasped by the sages throughout history. For millennia, mystics struggled to explain the ineffable concepts: unity, emptiness, the illusory nature of reality, the power of consciousness, using parables and simple allegories. Their language was poetic, yet imprecise. Today, however, physicists, using the rigorous language of mathematics, arrive at a description of reality that sounds strikingly similar. Quantum physics seems to be telling us, look, those strange things your prophets and saints spoke of, they weren't mere fantasies. The fundamental principles underlying the universe are indeed incredibly similar to their descriptions. This doesn't mean we should start praying to Schrödinger's equation, but it does mean we can use scientific discoveries to gain a deeper understanding of ancient wisdom, and conversely, use that ancient wisdom to make sense of the shocking revelations of science. But there's another, much deeper perspective on this connection. Some physicists, John Archibald Wheeler, for example, who was both a student of Bohr and a colleague of Einstein, developed the idea that the basis of everything is neither matter nor energy, but information itself. His famous principle, it from byte, posits that every physical quantity, every particle, every it, fundamentally originates from bits of information, from simple yes-no answers. In this worldview, the universe appears to be a gigantic quantum computer, constantly processing information, with the laws of physics serving as its core algorithm. And we, as conscious observers, are an integral part of this process. By posing questions to the universe through experiments, we force it to generate concrete answers, bits, out of the informational fog of possibilities, qubits. Under this concept, reality is not a collection of fixed objects, but rather a continuous dialogue, a process of co-creation in which consciousness actively participates. Once again, this echoes ancient mystical ideas that the world is merely God's dream, or that perhaps we are living in a sophisticated form of the Matrix. This brings us face to face with the ultimate question: where does God fit into this grand scheme? Certainly, quantum physics didn't find a judgmental, white-bearded figure sitting on a cloud inside the atom. It completely dismantled the deistic idea of the watchmaker God, the one who simply wound up the universe once and then walked away. But what it did do was open the door to an entirely different conception of the divine, one far closer to Spinoza's pantheism or the core tenets of Eastern philosophy. If, at its most fundamental level, the universe is a single, indivisible, non-local whole, if it emerges from the infinite ocean of energy we often refer to as the quantum vacuum, if it is permeated by underlying intelligence and information, and if consciousness plays a crucial, participatory role in its existence, then perhaps the very fabric of existence, the laws of physics themselves, this unified, intelligent, creative system, that is what humanity throughout the ages has called God. God is not an external entity. He is the intrinsic nature of reality itself. He isn't out there, detached. He is in here, woven into everything. And science, by studying the laws of nature, is in essence studying the very nature of the divine. So, where does this leave us? Did quantum physics ultimately prove the existence of God? Or did it merely validate the claims of mystics? The answer, perhaps surprisingly, is both yes and no. It didn't provide the direct, irrefutable evidence that would satisfy the most hardened skeptic, but it achieved something far more profound. It utterly shattered the old, mechanistic, materialist worldview, a framework that left no room for wonder, mystery, or spirit. Instead, it revealed that reality, at its most fundamental level, is something unimaginably strange, paradoxical, and deeply mysterious. It swung open the door to a universe where everything is profoundly interconnected, where the observer and the observed are fundamentally linked, and where apparent emptiness is, in fact, brimming with infinite possibilities. Quantum physics has built a crucial bridge between the strict, empirical language of science and the intuitive language of the spirit. It didn't hand us the final answer. Instead, it equipped us with the right questions, demonstrating that the most exhilarating exploration lies exactly on the boundary between the known and the unknowable. So let's wrap this up. Quantum physics didn't write "God exists" on a lab whiteboard. No, but it did something far more revolutionary. It shattered the rigid foundation of materialism and showed us a universe that feels less like a soulless mechanism and more like a living thought. A universe where everything is interconnected, where the observer influences the observed, and where emptiness is teeming with infinite energy. Doesn't that sound exactly like descriptions of the divine found in ancient texts? And here's the ultimate plot twist. Perhaps the most advanced scientists and the most enlightened mystics, travelling from different directions, have reached the same mountaintop, simply calling it by different names. Science didn't kill God. Maybe it just gave us a brand new way to perceive it. If this video made you think, please hit that like button and subscribe to the channel so you don't miss future explorations at the intersection of science and the unknown. And here is the big question for you. Where do you draw the line between science and faith? And do you believe they can ever truly merge? Let me know your thoughts in the comments below. I'm really looking forward to reading them. Thanks for watching, and I'll see you next time.